In this video, we'll learn about configuration management tools and how they can protect us against human error and inconsistent configurations. And that's the main problem we're trying to solve here. So anytime you have a human being manually configuring a network device, you are creating the opportunity for errors to occur. And many of our largest outages that we experience are often because of human error. We also have a tendency to see inconsistencies. So if we have many similar devices and they're set up manually by a human, you may see little inconsistencies between the configurations of those devices, which can potentially create big problems. And there's always the possibility of little typos or critical steps that may have been skipped. The other big problem with having human beings configuring all of your network gear is it is hard to scale. If we have hundreds of devices that now need to get updated or modified, having a human being do that not only takes more time, but creates the opportunity for more errors. So again, let's think about an analogy. By now, you guys know that I love to use analogies. Let's think about a restaurant chain, right? Think about your favorite fast food chain. If you go to your favorite fast food chain and you order yourself a hamburger, you know exactly what you're going to get. Now, imagine that each of those locations started making burgers the way that they wanted to. And you never know what you're going to get when you go and you order your favorite meal. It might be different every time. Configuration management tools are sort of like recipe books or standardization for networks. They're basically there to ensure that every time you order a hamburger, you know exactly what you're going to get. So that's the big benefit of configuration management is it provides standardization. Every device is going to follow the same rules and have a consistent configuration according to our standards. And by automating this process, we're reducing the likelihood of errors that human beings make, and we all make them. It also allows us to keep track of changes and roll back if needed. So let's imagine that you need to make a configuration change on 100 network devices. And later on, you realize that that change was wrong. How do you go back to the way things were? Well, if you've saved an old version of your configuration that you can just apply to all 100 of those devices, you could roll back immediately. And of course, configuration management tools are more scalable. We can configure 10 devices or 10,000 devices with the same amount of effort. It doesn't take any more work to add more devices. And some of the most commonly used configuration management tools include Ansible, Puppet, Chef, and SaltStack. And so you can play with these different tools and decide which one is best for your situation, but they all kind of work the same way. You're going to set up your desired state. They work with what we would call a declarative model where you're going to set up your desired state. And so let's take a look at what I mean by that. With these configuration management tools, we are going to define templates or playbooks. This is like our recipe for our hamburgers that we're going to standardize. So we are going to set up our standardized configuration, and then we are going to push that configuration to devices. So that's kind of like the automated initial setup, right? Let's say we have 20 routers. We want to configure them all. We define a template. We push that template out to all of those routers. And then we have a nice standardized configuration on them. And then the configuration management tool will work to maintain the desired state. So what I mean by that is it will consistently monitor and validate the configurations of all of those devices. And if we have what we would call configuration drift, it will remediate that. So let's say that somebody logs into a router and makes a manual configuration change that does not conform with our template or our playbook. The configuration management tool will detect that change and it will remediate it and bring that device back into its desired state. So once we start working with a configuration management tool, that becomes the way that we configure our devices. And if we start going into those devices individually and managing them individually, we're going to create configuration drift, and the configuration management tool is going to resolve that configuration drift for us. Okay, so let's imagine a real life use case to bring this all together. Let's say that we have a large retail chain, maybe there are stores, right? And within each of those stores, we have one switch and one router. That's inside of all of our stores. And let's imagine we have 500 stores. And so without configuration management, somebody's going to have to configure all 500 routers and all 500 switches manually. And over time, this is going to lead to outages and troubleshooting nightmares because the configurations might be a little bit different or they might be wrong in certain spots. Now, let's imagine we're using Ansible, for example. And Ansible is our configuration management tool. With Ansible, you create a single playbook, and the playbook is going to have all of the configuration information, like what should the VLANs be? Should we be using a dynamic routing protocol? What are the security policies that need to be configured in each of those devices? And then we take that playbook and we apply it to the routers in all 500 stores. And if somebody gets into those routers and maybe they start making manual configuration changes, Ansible is constantly monitoring the configuration and looking for configuration drift. It's looking for routers that do not conform with the desired state of our configuration. And if it finds a router with configuration drift, it will automatically correct that. And so the result is we have consistent configurations across devices. We have faster rollouts of new devices. And because of the elimination of human error, we have fewer outages.